Hi everyone, and welcome in this first part of this tutorial on how to solve equations graphically. Today we're going to work from the graph of y is equal to 2x minus x squared. So the graph is shown right there. It's a parabola facing down, and because of this x squared here is negative. And the first thing we need to do is really to remind ourselves of how we draw such a graph. So drawing a graph comes from a value table, as the one that you show here. And here we picked random values for x, or not totally random, but the values that we were interested in. It could have been any other value. And when x is equal to minus 3, we are going to work out the corresponding value for y. So if this x is minus 3, we have 2 times minus 3, which is minus 6. Minus 3 squared here is going to be 9, so we have minus 6 minus 9, it's going to be minus 15. Similarly, we can substitute x by minus 2 to find the corresponding y. So 2 times minus 2 is minus 4, minus 2 squared here is 4, so minus 4 is going to be minus 8, so we can write a minus 8 right there. And so on, so let's complete this table. The first point with coordinates minus 3, minus 15 cannot be plotted on this graph. But the second one with coordinates minus 2, minus 8 here can be plotted right there. The next one, minus 1, minus 3, is going to be this one. The next one, 0, 0, is obviously the origin of our coordinate system. 1, 1 is going to be right there, and so on. Once we have all these points, you see that we can nicely join them up through a smooth curve and get this parabola. So let's put this value table aside for a moment and try and solve some equations. Let's try and solve 2x minus x squared is equal to minus 3. So the one thing we need to keep in mind is that we need to use this graph. And this graph is a particular graph. It's the graph with this equation. So this means that for any point on this graph, if you take twice its x coordinate and subtract its x coordinate squared, you get its y coordinate. This is basically how we've constructed this value table here. So this 2x minus x squared here, you see this is this. It's actually equal to y. So this equation is equivalent to y is equal to minus 3. So the question we're asking ourselves is, for what values of x is 2x minus x squared equal to minus 3? And if we want to use this graph, this means that if 2x minus x squared is 3, then so is y on the graph. Okay, so this means that we need points for which the y coordinate is minus 3 on the graph. All the points whose x-coordinate is minus 3 are going to be somewhere on this line. So if you want y to be minus 3 and y to be equal to this at the same time, you have to look for these 2 points here. These are the only 2 points on your graph where the y-coordinate is minus 3. And now you can ask yourself, what are the corresponding values of x for which this occurs? And the corresponding values for x are minus 1 and 3. So this means that minus 1 and 3 are solutions to this equation. Let's check this. Twice minus 1 minus minus 1 squared is going to be minus 2 minus 1, and that's going to be minus 3. So we have the right value. Similarly, twice times 3 minus 3 squared is 6 minus 9, so that's minus 3. So these 2 values of x are indeed solution of this equation right here, and we've used this graph to find out about them. These checks that we've done here, you have to notice that it's exactly the same calculation we've conducted to find out about these values here in the value table. For 3, it would have been the next one. So let's summarize one last time. If you want 2x minus x squared to be minus 3, basically you want this to be minus 3. Okay, so this means that the y you're looking for here has to be minus 3, and this occurs here and there. And how does this show on the graph? It shows that for x is minus 1, the y was minus 3, and for x is 3, the y was also minus 3. So we've basically checked on this curve what points had a y-coordinate equal to -3. Let's now have a look at what would happen if the equation was slightly different, such as 2x minus x squared is equal to -1. So now we want this to be 1, so it's basically corresponding to the y on our graph. So we're looking for the points for which y is equal to 1. And this happens on this line right here. So now we only find one solution, and this is x is 1. You can check by substituting x into this expression here, that twice 1 minus 1 squared is 1 indeed. Finally, let's have a look at one last situation, and let's try and solve 2x minus x squared is equal to 0 here, this third equation. So again here, what do we want is y is equal to 0 on our graph. So this happens here on the x-axis, so we're basically looking for the point of intersection with the x-axis. So our two solutions here are x is 0 or x is 2. I hope this helps you understand a little bit more about how to solve some equations graphically, and if you want to learn about solving more complex equations graphically, you can watch the next episodes.